Today with inverse functions, we first need to talk about the existence of an inverse. And I briefly mentioned this in homework review, but we need to actually put it into notes. And if we put that in yesterday, let's just kind of add a couple things to it. So like I said, note, a function has an inverse if it passes the horizontal line test. A function has an inverse if it passes the horizontal line test. Remember, we can find out if something is a function by using the vertical line test. Well, here we're looking to see, does a horizontal line hit it in more than one place? And if it hits it in more than one place, then it does not have an inverse. All right? So obviously this one would not, but if I did just a straight linear, a linear would have an inverse because it only hits it in one place. All right? So you're going to have some questions where maybe they say, I'll put this as an example. Does the function have an inverse? So, some of this will boil down to your knowledge of functions in our function family, and some of them you may actually have to put in your graphing calculator to see. Let's just do an easy one. H of x equals the square root of x. We should all be able to graph that one without any help. If I graph this square root function, I know that it looks like that. So does it pass? It does. All right? So this is a pretty straightforward thing. This one, yes, does have an inverse. And we'll just do one more. How about f of x equals x squared minus x? Now, let's just say that I did not have a graphing calculator. Could we all graph that one? Well, this one has a little bit of a different shift to it. If I don't know where it's shifted, all right, because notice this one isn't written like this, x minus 5 quantity squared. Then I have to look at intercepts. And this is something we spent a lot of time on this year, is finding the intercepts. So if I set that thing equal to 0, this is actually a pretty quick and easy problem. I can factor out an x. I have x times x minus 1. Split this up, and I find out that x equals 0. X minus 1 equals 0, so x equals 1. So those are the two intercepts. And so that tells me how I can sketch this graph. Okay, so if I don't have a graphing calculator, I still should be able to graph most quadratics. So I know there's an intercept at 0 and at 1. So here and here. And my quadratic is going to go through those two. It is facing up since my x squared is positive. So does this pass the horizontal line test? No. Okay? Good review of finding x-intercepts, which we need to know how to do. Now, the main thing that we need to cover today is how to find an inverse function. I know that the other day we did it informally. We looked at simple examples like if the original function was 4x, then the inverse function was x divided by 4. That's pretty obvious. The inverse function will undo what the original function does. But there are functions that are more difficult than that, And what I want to do is give you some steps for finding the inverse. Steps. Number one, f of x does equal y. Okay, so let's replace the f of x with the y, because we have to do some algebra to get this done. So replace the f of x with y. Number two, switch x and y in the equation. All right? That's a critical step. If you don't do that, you'll never get to the inverse. And then number three, solve for y. So it's basically just some algebra. All right? So let's do one of these. You're going to be asked to find the inverse. Let's say that I have f of x equals 5 minus 3x all over 2. Well, let's just follow our steps. I know that f of x is the same thing as y. So y equals 5 minus 3x over 2. And now I have to switch the x and the y. I have to trade places with these two. So I need to rewrite this thing. So now it says x equals 5 minus 3y over 2. And now we have to solve for y. So what would be my first algebra step to solve for y? Multiply both sides by 2. Multiply both sides by 2 so I can get out the slasher. And I have 2x equals 5 minus 3y. Should be straightforward algebra steps from there. Subtract 5. 2x minus 5 equals negative 3y. Divide both sides by negative 3. And we're done. Now sometimes your book will rewrite this thing a little differently because of this negative down here. Sometimes they'll bring that negative up to the top. So if they did that, if they brought this negative up here and distributed it, then you would have 5 minus 2x over 3. You need to be aware of that. They do that some. So this answer, this is the inverse f to the negative 1. That's the inverse function right there. That problem is done. Now sometimes, as you can expect, they'll be more difficult than that. Let's do a more challenging problem, like this one. F of x equals 9x minus 7 all over 3x plus 4. Well, we replace f of x with y. So y goes here, equals 9x minus 7 over 3x plus 4. And now I need to trade the x and the y. So that means the x is going to be here, and I'm going to have 9y minus 7 over 3y plus 4. And I have to solve for y. Now don't get overwhelmed with this, and don't start making bad algebra decisions. What would I call a bad algebra decision? I would call a bad algebra decision saying, oh, I can factor out this 9 and this 3, right? And I can do this and this. No, you can't do that. Okay, that's illegal because these are connected here, all right, with addition. So what I would do is I would multiply both sides by the denominator first. I would multiply both sides by this. 3y plus 4 times that side and 3y plus 4 times this side. That's what I would do first. And that's going to get rid of this fraction on that side, which immediately helps us. Then I would use the distributive property here. All right? So I have 3yx plus 4x equals 9y minus 7. Now remember what we're trying to do. We're trying to get y by itself. So it makes sense for me to get the y terms on one side and everything else on the other. So what I would do next is I would subtract 9y from both sides, so I can bring that term over here. And I would also, let's just go ahead and do this in one step, I would also subtract 4x from both sides. And that way I can take the 4x over here. Trying to get the y terms together. All right? So look what I have now. I now have 3yx minus 9y equals negative 7 minus 4x, because those went away on that side and those went away on that side. Now we're getting closer. I have all the y terms together. So now we're going to use a little bit of backwards distributive property. I have a y term there, I have a y term there, I can factor it out. I can factor out a y. So if I pull out that y, I have y times 3x minus 9 equals negative 7 minus 4x. And that is a very important step, because now we just have one step left. To get y by itself, what's my last step? I need to divide by this entire quantity right here. So I'm out of room, so I have y times the quantity 3x minus 9 equals negative 7 minus 4x. So I'm going to divide both sides by this entire quantity, 3x minus 9. And on this side it goes away, and now I'm done. This is the inverse function. Negative 7 minus 4x over 3x minus 9. So it really boils down to how well can you do algebra. Be very cautious with your distributive property and your negatives. And we will stop there for today.